Greetings! This is Unit 7, Module 3, Session 2. The name of this home connection is Standard Algorithms. It's a two-pager. Put your name and number at the top, please, and let's begin. So we are to, and I can highlight this so you can see where I'm reading, use the standard algorithm to solve each multiplication problem. Standard algorithm. The nice thing is they did one for you. And you can see that they multiplied, let's find my 7 times 4, which is 28. They carried the 2, so here's the 2 and the 8, so they did 28. Then they took 7 times 3, which is 21, but whatever you carry up here, you must add. So 7 times 3 is 21, but when you add the 2 that you carried, you end up with 23. So your answer is 238. Let's do a couple together, please. I'm going to highlight the steps here, okay? I have 43 times 6, and I know that I'm going to start by taking 6 times 3. The second thing that I'll do is 6 times 4, okay? So let's do that. Let me get my black pen here. 6 times 3 is 18, but if in your first step you have to remember that you must carry the tens digit, okay? So yeah, 6 times 3 is 18. You're going to carry the 1. 1, 8, there's my 18. Step 2 is to take 6 times 4. We know that 6 times 4, I could write it over here. Didn't write it very well, but there it is 24. But we also must remember to add the 1 that we carried. So 24, and then I add 1, I should have 25, which I will put next to my 8. So the answer is 258. Okay, one more, and then I'm going to slow down maybe just a pinch on this one, make it even bigger. Why not, right? We have room. Step 1. Well, should I highlight my steps again? Yes. First thing I'm going to do is take 4 times 8. If I carry, then I carry. And then I'm going to take 4 times 2. That'll be my next step. So let's do the first thing first. 4 times 8 is what? 32. I have to remember to carry my 3, 32. Okay, that first step is done, the yellow part that I highlighted. Now I'm going to move on to the green step and take 4 times 2. Okay, because that's what the next step is, 4 times 2. We know that 4 times 2 is 8, but I must remember to add the 3 that I carried. So if I take that 8 and I add 3, I have 11, which I will write in my answer. 28 times 4 is 112. Okay? Let me look at the rest of these just to make sure there's nothing I want to cover, and I don't think I do. I'm going to let you do those remaining 5 problems. Number 2 says, solve the problems below using the standard algorithm. Show your work. So we're going from 2 digits to 3 digits. The only thing that you might have to do is carry twice, okay? So if I look at this first example, let's do the steps. I know that I'm going to take 3. Ooh, that's not what I meant to do. Let's do our highlighter, actually. I know I'm going to take 3 times 7. That'll be step 1. Step 2 will be to take 3 times 3, and then I will end by taking 3 times 1, okay? So I have to do all of those multiplications. And if I need to carry, then I must carry, okay? So let's do this thing. Let's take 3 times 7. If we do know our math facts, so that was supposed to be black. 7 times 3 is 21, but I'm going to need to carry that too. So I have 21, okay? Now I'm going to move on to my green step. And now that I've done 3 times 7, I'm going to do 3 times 3. 3 times 3, that's not too bad. 3 times 3 is 9. But I must remember to add my 2. Okay, so I'm just going to pencil that in here right there. Plus 2, 9 plus 2 is 11. But once again, since I have a number that's coming after that, I'm not quite done because I haven't done the blue step yet. Since there is a number next to it, I'm going to have to carry that tens digit, which happens to be a 1. So I have 11 like that. And I guess I could add my serifs here, okay? Now we can move on to the blue step, which is 3 times 1. I love it when they give us 1. That's not too bad. 3 times 1, we know that's 3. But don't forget, we have to add what we carried, which was a 1, 3 plus 1 is 4. That's going to be the final number that I write in our problem. Let's do one more. 382 times 7. Because I think it's helpful, I'm going to highlight it again. First thing we'll do is take 7 times 2, and we'll carry if we need to. I'm going to leave a box here just in case. Then I'm going to take 7 times 8, and if I need to, I'll carry a number here. And then I will take 7 times 3, and it doesn't matter if it's a 2-digit number or not. We will just write that answer right here, okay? So, and I'm going to get rid of that just so it's not too confusing. Okay, here we go. First step, 7 times 2. That's 14, but I have to carry this 1, so I have 14. Okay. What is step 2? The blue. 7 times 8. Woo, that's kind of a big one, but if you know your math facts, maybe it's not too bad. It's 56. And once again, 56. I have to carry this 5. That's why I put that blue box there. 56. Final step is to take 7. Ooh, did I finish that? I did not. Oh my goodness. Go back. Let me erase this. It is 56. I forgot to add my 1. Oh, don't tell anybody that I messed up. So add my 1. It's 57. Now I can do what I just did. 7. Carry the 5. Oof. Now I can move on to the green step. 7 times 3. Don't let me forget this time. 7 times 3. We did this in an earlier problem today. 7 times 3 is 21. This time I'm not going to forget my blue 5 up here. I need to add that 5 on. 21 plus 5 is 26. And since there's no number here, I don't have to carry the 2. I'm just going to write it, the whole number down here. So that is 2,674. Okay. I am going to highlight the next one for you. Ooh, why did that go over there? Let's put this over here. Okay, there we go. I'm going to do the highlights here. Maybe that'll help. Or at least I hope it helps. Oh my goodness, I need my highlighter. 6 times 5, okay? You'll put one of the digits here, and if you have to carry, you'll put it here, okay? In the second step, you'll take 6 times 8. You'll write one of the digits here, and you'll carry the tens here. In the final step, you'll take 6 times 4, and you will write both of the digits here. Don't forget what I forgot in the last one is you might have to add, if there's anything you write up there, you have to add it on, okay? Hopefully that color helps you a little bit. I like color, I like boxes, I like to know where things are. Hopefully that helps you too. There are some challenge questions down below. Nothing changes, except I need one more color. 5 times 3 will be first. 5 times 4 will be second. 5 times 2 will be third. 5 times 1 will be last. I might zip through this one, so stay with me, because I know that I'm going to be doing, what did I say? 5 times 3. I know that I'm going to be doing 5 times 4. 5 times 2. Sorry that my handwriting's bad. 5 times 1. Okay? Okay, step 1. 5 times 3. That's going to be 15. Make sure you carry this 1. Boop. Boop. Okay. Step 2. 5 times 4. Don't forget this one. 5 times 4 we said is 20. And if we add that 1, we have 21. Don't forget we need to carry this 2. So I'm going to put my 1 here and my 2 here. 21. Next step, 5 times 2. We know that 5 times 2 is 10. We're going to add that 2 on there. Don't forget to add the 2. That should be 12. And we're going to carry this 1. So here's my 2. Carry the 1. I'm carrying that 1 because there's still a number. If there's a number to the left of what you just did, you've got to carry it, okay? And then finally, in that last step, I've got 5 times 1. We know that math. 5 times 1 is 5. But I cannot forget to add that 2, add the 1. 5 plus 1 is 6. just simply write it down. Even if that was a 2-digit number, you would write it all right here because there's no number up here to carry. It's almost like that number falls down because there's no number to write it above. So my answer is 6,215, okay? I'm going to let you finish the rest of those problems. Take a minute. I've only spent 10 minutes on this page, so take a minute and do those problems. Solve each addition problem using the standard algorithm. You can see they did one for you. If you end up with a number that's more than 10, make sure you carry like they did here. I am going to do 1 with you, and I want to do this one here. Okay, so if I get my black pen out, I'm going to start with... I'm going to start here with 8 and 3, okay? 8 plus 3 is 11. I said it was going to be a black pen, and then I colored in red. And I must carry the first digit, so 11, okay? 7 plus 4 is also 11, but if I add this 1 to it, it becomes 12. Here's my 2. I carry the 1. And then I do 5 plus 3. That's 8. If I add my 1, that becomes 9. So in this particular problem, I had to carry twice because my addition problems made me more than 9. If it's 10 or above, you're going to have to carry a number. And that's okay because you need to be accurate. This is not the first time we've done the standard algorithm in addition, but if that helps you, then use it. Let's hop down to this 4 by 4. 8 plus 9 is 17. Make sure you carry the 1. 9 plus 2 is 11. Add the 1, 12. Carry the 1. 4 plus 0 is 4, plus 1, 5. 3 plus 4, 7. There's nothing up here to add on to, so that is just stays a 7, okay? Now here's where we're going to have a little fun with subtraction. Let me see if I can find a hard one. Whoop, right here. I'm going to start right here. This one is going to be the one. So I have 1,800 minus 925. Look, we have more on the floor. You know what that means. So when I see a 0 and I try to subtract 5, I can't. But it has a 0 for a neighbor. What do you do in that situation? Oh, goodness. Well, I like to say, whoever is after the 0, okay? So this is what needs a 1, okay? I'm going to borrow from not the 0, but the 0 and the next number that's not a 0. And I'm going to draw a box around it like this. I'm going to borrow from here. Rather than borrowing just from a 0 by itself, I'm going to borrow from the whole number. If I take 1 away from it, 80 becomes 79. Now I can borrow that 1 so that I have a 10. My 10 minus 5, I can do that math. 10 minus 5 is 5. I can also do this new number 9 minus 2, which is 7, and I can't do 7 minus 9, so I am going to come over here and borrow from this 1. If I borrow 1 from it, it becomes nothing, and then I can add the 1 to my 17, although that doesn't look like 17 when you draw it like that. Now it's a 17. Then if I take 17 minus 9, that makes a little bit more sense because 17 minus 9 is 8. My answer is 875. I really like those kinds of problems where you get to borrow from zeros because you get to use that strategy, which doesn't happen very often. I'll do one more with you. Ooh, this is going to be good. If you want to, do this one without me and then come back, okay? I'm going to start with 5 minus 7. Oh, no, there's more on the floor, so I go next door. It's a 0. Oh, no, I can't borrow from a 0 or another 0. So what I'm going to do is I'm going to box it, just like we talked about. And I'm going to draw a box around whatever I need to borrow from. Okay? Let me explain that again. I go next door, it's a 0. There's nothing to borrow from. We go next door again, there's nothing to borrow from. I can borrow from a 6, so that's how far my box has to go, okay? Whatever number needs more, we draw a box around the numbers to the left of it that you can borrow from. Can't borrow from a 0, can't borrow from a 0, can borrow from a 6. So once I put this all in a box, I can now borrow 1 from all of it. Let me move this down just a pinch. Oops, that's not what I wanted. Boop, there we go. And if I do that, that becomes, I need to do that better, 599. And then this 5 becomes a 15 because I borrowed a 1. Now I can subtract 15 minus 7, and that is 8, I do believe, if my math is correct. And I can do 9 minus 4, which I think is 5. Okay. 9 minus 3 is 6. And where's my arrow? 5 minus 1 is 4. So that answer is 4,658. The tricky part is going to be if you find a neighbor that you cannot borrow from, you're going to keep going until you find a number that's not 0 and then stop. If this number would have been maybe like 786,005, like if that was the whole number, gosh, it kind of doesn't look very good to draw it like that. Let me use a little bit bigger pen. 786,005. I still would have stopped at this 6 because that is a number that's bigger than 0. Okay? If that would have been a 0, like maybe like this, then my box would have kept going until I would have gotten a number that wasn't 0. So one of the things that we have to be really careful about is stopping at a number that isn't 0 when you're doing your box strategy for borrowing from zeros. All right, so I've talked to you quite a bit about that, and there are some balanced equations at the bottom. They want you to make the equation true. One of the tricky parts about this is trying to figure out what pattern they're getting at. When I look at this first example, 7,000 is on this side. I've got 670, and then I have something times 5 over here. Well, I mean, you could do it multiple ways, but if you wanted to do, let's say, a number line, you could think of, well, if I'm at 670, how far do I have to go to get to 7,000? And you could do things like, well, if I went up 30, I would be at 1,000. Sorry that my drawing's so terrible. And then if I went 2, 3, 4, 5, 6, 7, if I went up 6,000, I would then be at 7,000. So that distance there, 670 to 1,000, that's 30. And then I add 6,000 more to get 7,000. That would be a total of 6,030. Correct? So then you have a tough decision here. Wow. How many 5s do I have to count to get to 6,030? You could set up a ratio table. These are challenge questions, right? There's more than one way to do it. I'm just trying to use a strategy that you've used recently. Counting like 1 times 5 is 5, and you could figure out a couple different ways to do this. Well, I know that 5 times 1,000 is 5,000. Well, that gets me to 5,000. What if I just wanted to get to an answer that was 1,000? Okay. Well, I know that there are 20 in 100, so there must be 200 in 1,000. Well, now I'm up to 6,000. And then I know that 5 times 6 is 30. Add that on there. Now I'm at 6,030, which means if I add all of these, 1,200, oh my goodness, I need to work on that, 1,206, I know that would calculate to this 6,030 that we need to add to this 670 to get a total of 1,000. So once again, these are challenge questions for a reason, because you've got quite a bit of work to do. You could spend time subtracting what you know from the other side to figure out what's left. Not a bad strategy, right? Because you kind of need to know what's left. In other cases, you might be counting, 12 30s minus 3 times what is 114. That might require a few more steps, and that's okay. You might take 12 times 3 and then add the 0 back on, which would give you 360. And to you, you might be saying, wow, 360 is way bigger than 114. Yeah, how much bigger? Because whatever that answer is, times divided by 3 is going to go right here. They're challenge questions for a reason. And if you want to work on them, please do. And if you want to get more clarification with a math wizard, do that too. Okay, friends, it's been a long video, and I'm glad you made it this far. Like I said, if you have questions, ask for help. Check you later.